In the previous lecture, I have explained in detail how does binary search work. We have seen two dry tests. Okay, so in this lecture, I am going to show you the algorithm. In step number 1, what I am doing is I am initializing the value of LFT, which was used for storing the leftmost subscript, RT for storing the rightmost subscript of the array, MD to find the middle subscript of the array, right? So LFT plus RT divided by 2, right? So after that, I am going to apply the loop, repeat steps 3, 4 while LFT is less than or equal to RT. As you know, leftmost subscript should always be less than or equal to RT. How can leftmost subscript be greater than RT, right? So that is why this condition has been applied. Now the control will go to step number 3. That is the first statement of our loop. I am making the check if val is the value to be searched from the array. If val is greater than RMD, then what should I do is, as I have told you in the dry test, if value to be found happens to be greater than the middle element, RMD is our middle element. So in that case, the value of LFT should be changed, because now we are going to search only from the right sub array, right? Else, if val is less than RMD, that means the value to be searched happens to be shorter than, less than the middle element. In that case, the element will be found only on the left sub array. So what I am going to do is I am going to shorten the value of rightmost subscript, that is RT. So I would write RT is equal to MD minus 1, right? If suppose val is neither greater than RMD nor less than RMD, in that case what is going to happen is it is going to be proved that val is equal to RMD. So in last else there is no need to make any check. Last else definitely means that val is equal to RMD. That means the search was successful. So I will give the message found at location number MD, and return will return the control from this algorithm, right? And this is your end of a structure, right? And now suppose either the first condition or the second condition was true. That means we have not yet found the element. So in that case, either the value of LFT or value of RT has been changed. So in that case, we need to find out the updated value of middle subscript, that is MD. In that case, the control will go to step number 4, right? So the value of MD will be redefined, LFT plus RT divided by 2, as you have seen in the dry test also in the previous slides. Control will go up, condition will be tested. Again, these checks will be made. And if value is not found, either LFT will be updated or RT will be updated, and the value of MD will be updated. The loop will go on like this. Ultimately, if the value happens to be present in the array, this else is going to be executed, right? And found look message will be found at location number MD message would be printed. Otherwise, what will happen is, suppose the element does not happen to be present in the array. So ultimately what will happen is the value of LFT will be more than the value of RT. In that case, when the control will go up, this condition would be false, loop will break, and control will of course come to step number 5. Step number 5 will print the message no such value exists, and control will be returned back. Let me again tell you one thing, that if we are successful in our search, the element has been found, in that case somewhere along the execution of the loop, this else statements would be executed, found message would be there, and return will take the control back to the main algo. The control is not bound to go to this step number 5 or 6. The control will come to step number 5 or 6 only and only when this condition, while LFT is less than or equal to RT, is false. This condition being false means we were unsuccessful in finding the value from the array. Only then control will come to step number 5, and this error message of being unsuccessful in the search, that will be printed, right? So I would suggest you that you should write this algo yourself, and at the time of writing this algo, you should again make some dry test, and you should keep those particular diagrams of your array, ascending order array, that should be on your notebook. Only then you should go for dry test.